Choosing stepper motor and power supply is important for your CNC machine application. There are many stepper motors available in the market today, but standard motor we use for industrial application are just a few. So what's the standard motor means? Standard motor means in terms of build quality, performance, and reliability, they must be among the best. So for today demonstration, I'm using two standard motors we use for industrial application. One is Stepsin, made by a Japanese company, Sanyo Denki, and the other one is Blackstar stepper motor, also made by a Japanese company, Oriental Motor. These two brand name stepper motors are among the best. They are more expensive compared to non-standard stepper motor in the market. But how to get them? None of the CNC parts supplier carry those motors. Because how to get them? They both make different frame size stepper motors such as NEMA 17, NEMA 23, NEMA 24, and NEMA 34. NEMA 17 is mostly used for 3D printers and laser engraver. NEMA 23 and 24 are mostly used for CNC routers. And the biggest one, NEMA 34, is mostly used for CNC mill and CNC lathe. Today I'm going to talk about NEMA 23 and 24 we use for CNC router. Start with steps in. NEMA 23 frame size, lead wire type bipolar stepper motor. We like to use these two stepper motor. One is 103H7128-5740 2 phase, and the other one is 103H7128-5840 3 phase motor. Both motors are same size and produce the same torque, 2 Newton meter. The only difference is phase current. One is 2 amp and one is 3 amp. If you look at the speed versus torque curve, this is for 2 amp, this is for 3 amp. When you motor revolution increase, the torque is start sliding for both. So 2 amp motor torque decrease more than 3 amp motor. So in terms of performance, 3 amp motor is better than 2 amp motor. Connector type NEMA 23 frame size bipolar series. Sanyo also make 2 amp, which is this one. 3 amp, 4 amp, and 6 amp motors. Their size are the same, also produce the same torque, 2.5 Newton meter. So speed versus torque, 3 amp motor perform better than 2 amp motor, and 4 amp motor perform better than 3 amp motors, and 6 amp motor is among the best. For frame size, NEMA 24 bipolar stepper motor. Then you make 2-amp stepper motor, which is 103H7823-5760, and 4-amp per phase motor, which is this one, 103H7823-1760. This is the NEMA frame size, NEMA 24 frame size, and 60mm square flange. They will produce 2.7 Newton meter of torque. Speed versus torque are the same. 4-amp per phase motor perform better than 2-amp motor. High torque motor, NEMA 34 frame size, 86mm square bipolar stepper motor. They have 2-amp per phase, 4-amp per phase, and 6-amp per phase motors. And they can produce up to 9 Newton meter of torque. These motors are mostly used for CNC mill and CNC lathe. So I'm not going to talk detail of these motors in this video. Next is the choice for Vesta motor. I have a couple of Vesta motor I'm using with my CNC router for many years. But this time I am away from my motors, so I can only present you with photos and information from their catalog. So these two motors are NEMA 23 size, and this one is the one I have, NEMA 24 size, which is 60mm square flange. So these two PKB series, they have 2.8 amp per phase and 4.2 amp per phase. They both produce 2.5 Newton meter of torque, which is equivalent to 350 ounce-inch. So for 60mm square NEMA 24 size, they have PV269-D 2.8 AA model. This one produced 3.1 Newton meter, 440 ounce-inch of torque. So let's look at their speed versus torque chart. This is speed versus torque curve for PKB series stepper motor. This is for 2.8 amp per phase motor. This is for 4.2 amp per phase motor. If you compare these two charts, one motor reaches 300 revolutions per minute. The torque decreased to below the 1.5 Newton meter. So for 4.2 amp per phase motor, same speed at 300 RPM, the torque is still above the 1.5 Newton meter. So obviously 4.2 amp motor perform better than 2.8 amp per phase motor. So the other one, PV269-D 2.8 AA, is the one NEMA 24 60mm square size. So this motor is high torque motor and is offer it will produce a 3.1 Newton meter of torque, equivalent to 440 ounce-inch. But if you look at the speed versus torque chart, at 300 RPM, the torque is below the 0.5 Newton meter. So this motor is not a good choice for X6 or Y-axis. But since this motor offers the highest torque, it is good to be used on Z-axis, because the axis need to hold the spindle cutter and need powerful torque. So this motor is my choice for Z-axis. Now it's come to stepper motor choice for GECKODRIVE G540. So since GECKODRIVE G540 can drive up to 3.5 amp per phase motor, I'm choosing this 3 amp stepper motor for X86 and Y86, and this 2.8 amp Vector motor for Z86. This motor is the higher torque among the 3 amp stepper motor range. So for those of you who are looking for a cheaper stepper motor to be used with GECKODRIVE G540 driver, I found two motors. So these two motors. So both are NEMA 23 size, and this one is from CNC for PC. This one is 3.5 amp per phase motor, so it's exactly fit with GECKODRIVE G540. You don't need any current set resistor if you choose this stepper motor. And the other one is open wheels bipolar stepper motor. So this motor can produce up to 345 ounce-inch. So it's big. They both are bipolar motors. The only difference is this motor step angle is 0.9 degree, and this one is 1.8 degree. So you need to consider about those differences. So this one is selling for $50, and this one is selling for $44. So these two motors will be a good choice for GECKODRIVE G540. Let's talk about power supply. When we choose the power supply, some people like to use regulated power supply like this one, and some people want to use unregulated power supply because they have fear of pulling too much current during the motor start up and reaching the fair one motor is stopping. But I'm using this regulated power supply with my CNC router for many years, and I never have such experience. The rule of thumb is that power supply must be capable of supplying 2/3 of motor phase current. For example, if your motor is 3 amp per phase, power supply need to be capable of supplying about 2 amp. So multiplied by full motor is going to be 8 amps for a full X6 system. So this minimum power supply is 350 watt, 48 volt, 350 watt power supply I choose for my GECKO G540 drive. This one is capable of supplying up to 7.3 amp. so which is good enough to drive for 3 amp stepper motor. If you are using 4 amp of phase stepper motor or above 4 amp, you can use 2 power supply or 1 each for every driver. So it's up to you. For now, I'm going to stop my video here. And thank you for watching.